Hello, my class. Welcome back to math. Today we are going to be getting into the second half of our chapter and starting off strong with squares and square roots. And so this is going to be doing the opposite of exponents. So square roots are the opposite of squaring. If you remember from when we talked about exponents, squaring is when we have something like 3 to the power of 2, or 4 to the power of 2, or 5 to the power of 2, or 6 to the power of 2. Anything to the power of 2 is squaring. And so solving those, we just multiply it by itself. So we would say 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. These are examples of squared numbers, or these are what are called perfect squares. These are perfect squares because they're the result of squaring a number. Anytime you square a number, it's considered a perfect square. And so this is squaring, going from here to here. To square root, we use the root symbol that looks like this. This is the square root symbol. And this does the opposite of squaring. So if I want to say, all right, what is the square root of 9? Well, that's 3. What is the square root of 16? That's 4. Square root of 25 is 5. Square root of 36 is, yes, it's 6. So this is just doing the opposite. This is going backwards when it comes to squaring. Okay, so we want to really make sure that we have an understanding. Square rooting isn't really something that we're going to be able to perfectly calculate so well, and there's not a simple, easy formula to use to square root. Square rooting is really going to be, all right, do you know the list of square roots? So I'm going to write down the list of square roots, and I want you to write these down too, because it'll be really helpful as we move forward to know these lists of squares and square roots. Okay, so we have 3, 4, 5, 6. We'll go with 2 and 1. That would be 2 squared is 4, 1 squared is 1. Go 7 and 49. Come over here, we'll do 64 and 8. 81 and 9, 110, 121 and 11, 144 and 12, 169 and 13, 196 and 14, and then 225 and 15. Go ahead and pause this. Write down all of these square roots. You're going to want to have these written down so that we can go back to them as we continue through this chapter. All right, so as we're moving on from that, I'm just going to leave this over here, but we're going to deal with some other things. So when you square root a number, like the square root of 81. The square root of 81 is the same thing as something times something else. And we know that this something is 9 times 9. So the square root of 81 is 9. The square root of 81 might also be done by doing a different math problem. Negative 9 times negative 9. So the square root of 81 might also be negative 9. It could be either one because when we're timesing negative times negative, that's positive. 9 times 9 is 81. Okay, so when we say what's the square root, normally it's going to want the positive version. If it wants the negative version, it'll say something like, what is the negative square root of 81? That would be negative 9. What it's not going to do is say, what is the square root of negative 81? Do you see the difference here? The difference in these two? One of them has the negative sign inside. Whoops. One has the negative sign inside and one has the negative sign outside. If the negative sign is outside, that's okay. We can do that. If the negative sign is inside, there is no solution. There are not two numbers that multiply together to equal negative 81. It doesn't work that way. Okay, so negative numbers don't work like that. All right, so there's some understanding in the positives and negatives. One more thing I want to talk about is solving some square root equations. Okay, so let's say I have something like, say I have 2 times the square root of 25 minus 4. All right, 2 times the square root of 25 minus 4. Square roots here fit into the P in PEMDAS. Square roots are like a parentheses. You need to solve everything inside and then solve that square root before you can move on. So in this instance, we would write this and we would say, all right, well, let's solve that square root. So we have 2 times, what's the square root of 25? It's 5 minus 4. 2 times 5 is 10 minus 4 is 6. There would be our answer. Okay, so PEMDAS, the P in parentheses, is also for square roots. Solve out all your square roots before you do anything. Let's say I have the square root of 16 over 4 plus 3. Okay? And we would say, all right, well, let's solve our insides here first. Let's solve 16 divided by 4. This is square root of 4 plus 3. Square root of 4 is 2. 2 plus 3 is 5. Okay, so making sure you solve everything inside the square root before you continue. And that is our introduction to square roots. Good luck. We'll work on this tomorrow. I can't wait to see all of you. Be good. Goodbye.